It is now coming. Be careful. Right, so we want to find HCF and LCM using prime factor stuff. Okay, so what we're going to do is we're going to find the highest common factor and lowest common multiple, but we're going to start with a couple of easy numbers. Right, I don't want you to tell me what the answers are because it's easy. These ones are easy. Okay. We want to develop our method using easy numbers so that we've got a method for potentially harder numbers. And we're going to do it using prime factors. Okay? So, the first thing I want to do is do a prime factor decomposition, or split my numbers into prime factors. So, let's do 15 first. What is it? So, 3 times 5. Now that's already prime numbers. Okay, so we've stopped. Right? 20 is 2 times 10. 2 times 5. So we've got 2, 2, 5. Okay. Now I'm going to introduce you. It's not the way they do it in the book, but I'm going to introduce you to another thing. Well, maybe I'm not introducing you to Venn diagrams. Yeah?
I've never done them before. Yeah. No,
Never?
No, we didn't them last year.
I think you probably have done them. But what we're going to do is use them for this task. Okay? So, for instance, I'm going to use them to write down the factors of 15 and 20. Right? The prime factors. And this region here represents numbers that are what?
They both have the same factor.
They both have the same factor. So that gives you this common word. So any number that appears in both sets is right in the middle. So that would be a 5. Okay? So 5's dealt with. And then anything that's left over I can write in circle. 2, and that. Alright, so 15 is 3 times 5, 20 is 2 times 2 times 5. Okay? Now, using this diagram, we then know that this number is the highest common factor. Alright? The highest common factor. Because it's the factor that's common to both, that's why it's in that region. If there was another number that was in the middle with 5, what would you do? Sushi?
Choose which number was the bigger number and put that as a high HCF.
I see what you're thinking, but it's not true. It's not right. What would you do, actually? If there was another number in there with 5, what would you do?
Is it what times, like, by the least amount of times, like to get to 15 or 20? That is the highest?
No, I said, what if there was another number in this region with the 5, the highest common factor? Is that what you were trying to answer?
Yeah.
I don't think so. I don't think what you said. I didn't really get it. But Izzy, what do you?
Well, if there was 2 in there, it would be the one that's the highest.
See, yeah, I see it. I think that's what Sushi was saying though. But actually, it's not. It's not. What do you reckon, Camille? You would times them together, yes. So if there was a 2 in here as well, you would have to multiply the 2 times the 5. The highest common factor would be a 10. But we'll have a look at that. Now, so that is the highest common factor. In this case, it's 5. Do you agree? Highest common factor of 15?
Yeah.
Yes.
Right. The lowest common multiple is multiplying all the numbers together. So 2 times 2 times 3 times 5, which is 6 times 10 is 60. Now, here's the thing. You haven't multiplied all of these numbers together because you took away one of the what? The 5s. One of the 5s went because it was in that common section. Okay, so basically to find the lowest common multiple, you multiply all the factors together apart from any common factors. You leave one set of them out. Okay, make sense? Okay, So if we were to have another go of find the HCF, you can do this one now, and LCM of, what should we do? Something a bit more, let's do 36 and 24. I'll take a bit of multiplying at the end.
Is the objective just?
The objective was up there. Use prime factors to find HCF and LCM. So, do you want to, if you haven't made your notes, let me just zoom out. Right, let's have a quick look. So we are looking at doing, yes, we are good. 36 and 24, alright? So, let's do, I'm going to draw my Venn diagrams. Okay, I don't like that, I have to keep selecting actually.
Please forward out a compass.
Okay, 36 and 24. Now I'm going to use a different method this time. I'm not going to use the branch method. Up to you what you do. So I'm going to do 36. Okay, I'm going to use this method for anyone that might have done division like this. So 36, I'm going to try and divide by 2 first. Gives me 18, so 2 times 18. 18 is 2 times 9. Okay, and that is 3 times 3. Okay, and then we're done. Alright? So my list for 36 is 2 times 2 times 3 times 3. Is that true?
Yes.
Yeah?
Yep.
Good with that? Right. 24, okay, is 2, which makes 12. That's 2, which makes 6, which is 2 and 3. Okay. So what I do, just remember, this middle section is where I write any numbers that appear in both lists. So I've got a 2 there and a 2 there. So I'm going to write 1, 2. I've got another 2 and another 2. Then I've got a 3 and a 3. Okay? So what I do is instead of writing both of them, I take this pair and I stick a 2 to represent that pair. Then the next pair I put a 2. So I don't put both of them in, and then I put a 3. So that covers all of those factors. Then 36 is remained with 3. 24 has 2 left. Okay? Is that what you were doing?
Yep.
Mm-hmm.
So then, the highest common factor is,
12.
just to write it out, 2 times 2 times 3 is 12. And the lowest common multiple is, well, if I write again 2 times 2 times 3 times 3 times 2, so it's basically 12 times 6 is
No,
72. What's your question then, Ben? Sorry,
I might have done something wrong.
I'm getting the answer of 64. What? Yeah, I know.
It's because there's nothing next.
Well, I'm asking the question, right? I'm asking you whether you're checking. Are we happy with that result?
Yes.
Yeah?
Yeah.
No problems with that at all.
This could be a trick question.
Well, I'm just asking to check. I'm just checking Ben's work. He wrote 36 and he's done his split up as 12 times 3, 6 times 2, and 3
Oh,
times
3
3.
times 2.
There you go, Ben. Okay. It's always worth spotting it, isn't it? He was saying he didn't have the same, and we're like looking at that going, where's the mistake? Where's the mistake? It's an obvious one. It's people do it. They go into adding rather than typing.
I still got something wrong. I think.
Yeah?
Oh well.
And what about 24? We've got 3 and 8, so he did, instead of 2 times 2, 3 times 8. And then we've got
4 times
4 and 2, and then we've got
2.
2 times 2. And that's alright, isn't it?
But then, like, it doesn't make the 2, 2, 3. But
24, 2, 2, 2, 3. Yeah. 36, 2, 2, 3, 3. So that should have been a 2 there, shouldn't it? So 2, 2, 3, 3. Got the same.
okay, the one, right, okay.
Yeah, that's what made the problem, was your 36. Yeah.
Does the order of like the HCF and the LCM, how you times it, doesn't matter?
No, because if you multiply lots of numbers there, you can't do it you can't get it wrong by doing it in different order, can you? The only things, guys, when you add, you can add in any order, yeah? When you multiply, you can multiply in any order. When you divide, you have to do it in the right way, don't you?
Yeah.
And when you subtract, you have to do it in one way, okay? 4 subtract 2 is not the same as 2 subtract 4. 8 divided by 2 is not the same as 2 divided by 8. Okay, so you've got to be careful. Alright? Okay, so that's example. You've got a few questions to carry on doing in your book.
Yes.
You have 2 minutes. Hello, we've got 2 minutes to carry on. Just start it off.
We have until 3 hours. Yeah, it was never.